Welcome to this session on system integration testing. This crucial phase in the software development lifecycle ensures that different modules or components of a software system work together seamlessly. SIT follows unit testing, where individual components are tested in isolation. Its primary focus is on the interfaces and interactions between these integrated units. System integration testing verifies that distinct modules, when combined, function correctly as a group. It checks the data flow and communication paths between these integrated components. The goal is to uncover defects that arise from the interaction between modules rather than within a single module itself. These integration issues are often complex and can be difficult to diagnose later. A main objective is to validate the interfaces between modules. This includes checking data formats, protocols, and the sequence of operations. SIT also aims to ensure that the integrated system meets the functional requirements specified in the design. It confirms that the combined parts deliver the expected business logic. Identifying defects early in the integration phase is significantly more cost-effective than finding them during later stages like system or user acceptance testing. Quality assurance engineers play a vital role in SIT. They are responsible for designing test cases that specifically target the interactions and data exchange points between modules. QA engineers execute these integration test cases, meticulously documenting the results. They identify, report, and track any defects found during the testing process. Furthermore, QA collaborates closely with developers and other stakeholders to ensure that reported bugs are understood and fixed promptly. They also perform regression testing to verify fixes and ensure no new integration issues are introduced. Consider an e-commerce application. It typically involves modules for user authentication, product catalog, shopping cart, and payment processing. During SIT, we would test scenarios that involve the flow of data between these modules. For instance, testing the process where a logged-in user adds an item from the catalog to their shopping cart. This involves the authentication module passing user details to the cart module, and the catalog module providing product information. SIT verifies that this data transfer and the resulting actions occur correctly across all involved components. Another example is the checkout process, which integrates the cart, payment, and potentially shipping modules. SIT ensures that the total amount from the cart is correctly passed to the payment gateway and that the transaction status is communicated back. These tests reveal if modules are incompatible, if data is lost or corrupted during transfer, or if the sequence of operations is incorrect when modules interact. System integration testing is an indispensable phase for building robust and reliable software systems. By focusing on the interactions between modules, SIT helps catch critical defects early. The diligent work of QA engineers in designing and executing comprehensive integration tests is key to delivering a high-quality product that functions as a cohesive whole. Understanding SIT is essential for anyone involved in software development and quality assurance. Subscribe to QA Hub for more hands-on QA content. Like and share if this helped you understand SIT better.